June 1816. A farmer steps outside expecting the warmth of summer. Instead, he sees something impossible. Snow, not on distant mountains, not in the middle of winter, on his crops. In June, within months, crops would fail across 3 continents. Grain prices in parts of Europe would more than double. Families would starve. Historians now estimate that tens of thousands died as a direct result of what followed, and no one knew why. Across Europe, people whispered that God was punishing them. In North America, the cold simply refused to leave. The real cause lay 8,000 kilometers away, and it had already happened more than a year earlier. The year 1816 should have been ordinary. Instead, the seasons stopped behaving like seasons. Snow fell in June, frost returned in July. In some places, even August brought freezing nights. Here's the strange part. Scientists studying ice cores and tree rings later calculated that the global average temperature dropped by only around 0.4 to 0.7 degrees Celsius that year, barely enough to notice on a thermometer. So why did it feel like the end of the world? Because farming doesn't run on yearly averages. It runs on a narrow growing season, and that season needs consistent warmth at exactly the right weeks. A single hard frost in July at the moment grain is ripening can wipe out an entire harvest, and even if the rest of the year is unremarkable. That's what made 1816 so brutal. The damage wasn't spread evenly. It landed in the handful of weeks that mattered most. Fields that should have been green turned brown. Livestock died for lack of feed. Bread became a luxury. In parts of the United States and Canada, thousands of families abandoned failed farms and pushed west, hoping to find land where the frost hadn't reached. In Switzerland and Germany, food riots broke out. In Yunnan, in southern China, opium poppies, which needed less water and tolerated the cold better than rice, replaced staple crops on a scale that would reshape the region's economy for a century. Nobody connected any of it. To the people living through it, the weather itself had simply stopped making sense. Without satellites, without weather forecasts, without any real atmospheric science, people reached for the explanations they had. Some believed the end of the world had begun. Others blamed comets or sunspots or divine punishment for the recent Napoleonic Wars. Newspapers described blood-red sunsets and skies that stayed gray for weeks. The English painter J.M.W. Turner, in fact, painted unusually vivid, saturated sunsets during this period, and some atmospheric scientists today believe those colors were a direct artistic record of volcanic haze in the sky, though this remains debated among art historians. Whatever the explanation, one thing was clear: the sky itself looked wrong, but the answer wasn't above Europe at all. It began nearly 15 months earlier, on a small island in what is now Indonesia, a place almost no one in Europe or America had ever heard of. April 10th, 1815, a mountain called Mount Tambora exploded with a force modern volcanologists rank at 7 on the Volcanic Explosivity Index, roughly 10 times more powerful than the 1991 Pinatubo eruption in the Philippines, which is itself the eruption most people today would recognize. People more than 2,000 kilometers away, on islands they couldn't even see Tambora from, reported hearing what they thought was cannon fire. Entire villages on Sumbawa disappeared beneath ash and pyroclastic flows. Historian Gillen Darcy Wood, whose book Tambora, The Eruption That Changed the World, remains the most detailed account of the disaster, puts the direct death toll near 10,000, and the total, including the famine and disease that followed across the Indonesian archipelago, at over 100,000. But Tambora's furthest reaching victim wasn't Indonesia, it was the planet's atmosphere. The eruption threw an estimated 60 megatons of sulfur dioxide into the stratosphere, the layer of air roughly 15 to 50 kilometers up, well above where weather normally happens. Up there, sulfur dioxide reacts with water vapor to form fine sulfate aerosols, microscopic droplets that don't fall as rain. They just stay there, drifting for 1 to 3 years. Picture wrapping the entire Earth in a thin, invisible haze. Sunlight still gets through, but a portion of it is now scattered back into space before it ever reaches the ground. The planet cooled. Not everywhere equally, and not forever, but long enough and unevenly enough to break the growing season across 2 hemispheres at once. One mountain, on one island most people couldn't find on a map, had altered the climate of the entire world. The consequences reached almost every inhabited continent. Harvest after harvest failed. Grain prices in parts of Europe rose by as much as 300%. Typhus outbreaks followed the famines, particularly in Ireland and Switzerland, and yet, even inside this disaster, history took some strange turns. Near Lake Geneva, relentless summer rain trapped a group of writers indoors for days on end. Bored and restless, they challenged each other to write ghost stories. One of them was 18-year-old Mary Shelley. What she wrote that summer became Frankenstein, a novel now considered one of the founding works of science fiction. Elsewhere, a shortage of oats and hay made keeping horses too expensive for many. A German inventor named Karl Dreis, looking for an alternative, patented a 2-wheeled, human-powered running machine in 1817, the direct ancestor of the modern bicycle. Without meaning to, a volcano on the other side of the world had reshaped literature, transportation, and the migration patterns of two continents, all inside about 18 months. Today, atmospheric scientists understand this mechanism well, and it has a name: a volcanic winter. When a large enough eruption punches sulfur dioxide directly into the stratosphere, it doesn't wash out the way ash does in the lower atmosphere. It lingers, forms aerosols, and spreads globally within months, reflecting incoming sunlight and cooling the surface below. This is the same basic physics behind Pinatubo's smaller, roughly 0.5 degrees Celsius global cooling effect in 1991 and 1992, just at a much larger scale. It's also the same principle some scientists have proposed, controversially, for deliberate geoengineering to counter climate change today. Tambora remains the most powerful eruption in recorded human history, and the clearest large-scale example of a single geological event disrupting climate, agriculture, and society across the entire planet, not for a season, but for years. The people of 1816 believed they were witnessing the end of the world. They weren't. They were witnessing, without any way to understand it, the astonishing reach of a single natural event. It began with one mountain on one remote island, 60 megatons of gas, and 18 months of drifting haze. And it ended with snow on farms, an ocean away, a monster born in a rented villa by a Swiss lake, and a wooden machine with two wheels that would eventually become how half the world gets to work. History remembers 1816 as the year without a summer. Maybe it should also be remembered as the year the world discovered, the hard way, just how connected it really was. Because sometimes the biggest turning points in history begin in a place nobody was watching. If you enjoyed uncovering this forgotten chapter of history, don't forget to like this video, subscribe to Chronoscope, and join us as we uncover more incredible stories hidden in the past. Until next time, keep looking beyond the obvious.